As promised, this is the second half of the worksheet that we saw in class today. I'll go through the second side of the paper. I'm working on my kitchen floor because I needed to plug in my video camera, unfortunately. So hopefully my pen won't poke through, my dog won't lay on top of everything, and the cats won't get involved. So the next problem, chlorine can replace bromine in bromide compounds, forming a chloride compound and elemental bromine. The following unbalanced equation is an example. Now I didn't give you the equation, but we do see that potassium bromide is one of the reactants and chlorine is the other. So it would be chlorine plus potassium bromide. And again, I'm sorry, I have some graining on my floor, so it's not as clear as it should be. Will yield potassium chloride, because this is the more active element, it becomes the ion. It's now chloride with a -1 charge, plus bromine. If you remember your Hofbrinkel, Br is part of that. So if I have two bromines on that side, I need two bromines on this side. Make this a little bit neater. Two bromines going in. That means two potassium. That means I need two potassiums here. And I have my potassium chloride. Okay, so when 1.855 grams of chlorine and 3.205 grams of potassium bromide are mixed, which is the limiting reactant? So I have 1.855 grams of Cl2. I always just like to write things to set things up. 3.205 grams of potassium bromide. So that's all. I just took some of my data and I put it there. Now I need to manipulate it. So my first manipulation will be changing chlorine gas into moles. So 1 mole over, remember this is chlorine, so it's approximately 35.5. 35.5 times 2, or technically 35.45 times 2, would be around 70.9 grams of chlorine. That way my grams cancel out, and I end up with 1.855 divided by 70.9, 0.0261 excuse me, 6 moles. Excuse me. Now, did I actually need to go out 4 sig figs? I started with 4 sig figs. This is pretty close. Would I really be better with 3 sig figs? Yeah. Is it really that big of a deal right now? No, because we're just trying to find out which is the limiting reactant. My other one is 1 mole of potassium bromide and the gram molar mass of potassium bromide, which is approximately 39.1, plus bromine is 79.9. So I'm at 119 grams. So now I have 3.205 divided by 119 equals 0.02693 moles. Now, is there any other manipulation I need to do? Not exactly. Let me check my alignment so we can still see. Not exactly, because I have this value, this value, and this value. They're almost equivalent. But if I look here, for every 1 mole of chlorine, I need 2 moles of potassium bromide. So if I had, we're going to use this, let's say this is 0.03, I would need 0.06 of this. I do not have 0.06 of this. So therefore this is limiting, because I would need a whole lot more. If I set this up, I have 0.02616 moles of Cl2 times 2 moles of KBr over 1 mole of Cl2. So my moles cancel out. I would need double this value, and I don't have that. Now in this particular case, it's saying how many grams of each product are formed. So in that case, I need to find out the moles of product based on the mole ratio. So what I have to work with, I have 0.02693 moles of KBr. Why am I using that as my reference? Because this one runs out. When this runs out, the reaction stops. So then we go through 0.2693 moles of potassium bromide. And then my mole ratio is, we're looking at potassium chloride for example, 2, because that's my product, 2 KCl over 1 mole KBr. And to be consistent and to make sure I'm writing all this properly, 1 mole KCl over 1 mole KBr. That way these cancel out. I'll end up with how many moles of potassium chloride I produce. And actually, I probably need to edit this, so I just messed up. 2. The mole ratio is 2 to 2. Is that the same as 1 to 1? Yes, but that's how I can keep it consistent. As long as I do everything the way I'm supposed to, it's not going to lead me wrong. Could I reduce this to 1 to 1, which is actually what I just started doing? Yes, but I don't need to. So in this case, I would do 0.02693 times 2, and then divided by 2. It means these canceled out. I get 0.02693 moles of potassium chloride is produced. And then I do the same for my bromine, 0.02693 moles of potassium bromide times, and now in this case I have 1 mole of bromine over 2 moles of potassium bromide. And I should keep moles just so I'm being consistent here. 2 moles of potassium bromide. My moles of potassium bromide cancel out. I'm left with moles of bromine, which is what I want. So therefore I go 0.2693 divided by 2 basically is 0.0135 moles of Br2. Now that is not my answer, because it says how many grams of each product were formed. But I do have the moles, so I'm very close. Now I just have to multiply each one by the gram molar mass. So in the case of potassium chloride, that's 39.1 plus approximately 35.5, which is 74.6 grams. And in the case of bromine, bromine is 79.9 times 2, which is 159.8 over 1 mole. My moles cancel out, my moles cancel out. I end up with 0.02693 times 74.6, which equals approximately 2.00 or 2.01 grams of KCl, and I end up with 0.0135 times 159.8 grams, which is 2.15 grams of bromine. So that's based on my original limiting reactant. Yes, these are very long problems. I have one more, but I think I'm going to take a very short stop to adjust the camera and make sure I'm getting all of this properly. So let me align it properly. I'd rather not have to edit these videos. That'll take me a lot longer. Okay, so here we go. A process by which zirconium metal can be produced from the mineral zirconium 4 orthosilicate, ZrSiO4, starts by reacting with chlorine gas to form zirconium 4 chloride. Okay, so we see zirconium 4 orthosilicate already, ZrSiO4, and then it's being reacted with chlorine gas. Now this will not be a balanced reaction to start. It will yield zirconium 4 chloride, and it will also form, now again, you wouldn't necessarily be expected to know this, but it will make silicon dioxide, which is quartz or glass, and oxygen. Now, as far as balancing this, I already have one silicon on each side. I actually have 4 oxygen on both sides. The only issue here is that I need 4 chlorines and I only have 2. So I put a 2 here and it's actually balanced. Now it's saying, what mass of zirconium 4 chloride can be produced if 862 grams of zirconium orthosilicate and 950 grams of chlorine are available. So first thing you're going to have to do is find your limiting reactant, which as always is a matter of going from grams to moles. So in this case I multiply this by 1 mole over the gram molar mass, so zirconium is 91.2 plus silicon, which is 28.1, and plus 4 oxygens, which would be 64. So my gram molar mass here is 183.3 grams. So I'm dividing 862 by 183.3. Which gives me 4.7 moles. 4.70 moles of zirconium orthosilicate. Just make sure I'm still on the camera here. I apologize for all the blurriness. It's having a little bit of a struggle, but we're almost there. Okay. After that, 950.0 grams of chlorine. Again, multiply that by my 1 mole over the gram molar mass for chlorine gas, which is approximately 70.9 grams. Okay, 70 point... Don't like these mechanical pencils. 70.9 grams. So that would be 950 divided by 70.9, which equals 13.2 0.399, basically 13.40 moles of chlorine. Now the mole ratio here is 1 to 2. If I have one of these, I need two of these. So if I need, let's say, 5 of these, I need 10 of these. I have more than 10, which means that my limiting reactant is the zirconium orthosilicate. From there, I know how many moles I have. The nice thing here, it's saying how much zirconium for chloride will be made. Well, if I noticed, the moles of zirconium orthosilicate are the same as the moles of zirconium chloride. It's a 1-to-1 ratio. So if I have 4.70 moles of this, I would make, because it would just be 1 mole zirconium 4 orthosilicate, zirconium 4 chloride over, over 1 zirconium orthosilicate. I don't know why I'm spending so much time, I'm just going to cancel it out anyway. But I end up getting 4.70 moles I get 4.70 moles of zirconium 4 chloride. Of course, that is not the actual answer. What I need to do now is find the gram molar mass of zirconium 4 chloride. So zirconium, as we said, well, chlorine is 35.45. Multiply that by 4 is 141.8. Plus zirconium, which is 91.2. So my gram molar mass is 364.8. So what I do is my 4.70 moles of zirconium 4 chloride times 364.8 grams over 1 mole gives me 1,714.56. So basically 1,715 grams of zirconium 4 chloride. That is my answer. Let me circle my other answers just so when I post this online, some people just want to check the answers. They can see what they are. Okay, we have one more problem. Let me adjust the camera so we can see it. Sorry if I made anyone dizzy there. Alright, so last problems. In the following unbalanced reaction, what mass of barium nitrate can be formed by combining 55 grams of barium carbonate and 26 grams of nitric acid? So what are we putting together? We're putting together barium carbonate and nitric acid, and we're making barium nitrate and something else. First thing, I have 1 nitrate, I need 2. If I put a 2 here, I'm taking care of my nitrates. My bariums are taken care of. What else do I form here? Well, again, I wouldn't expect you to know this, but one of these oxygen pops off, finds 2 of the hydrogens, and makes H2O, and also this now, once 1 oxygen's missing, becomes, I'm going to run out of lead, CO2. That would be bubbling off. That would be your sign of a chemical reaction. Now that's balanced. I have 1 carbon, 2 hydrogens, 2 hydrogens, 3 oxygens, 2 nitrates, 1 barium, 1 barium. Okay. So I have 55 grams of barium carbonate, and I have 26 grams of hydrogen nitrate, which would really be nitric acid. This would be a solid in nitric acid. Okay, so first thing I need to do, grams to moles. That's always the best option. So barium is 137.3 plus carbon, which is 12, plus 3 oxygens, which is 48. That gives me 197.3 over 1, that's grams, over 1 mole. Same thing with hydrogen nitrate. 1 plus 14 is 15, and then 15 plus 38, 15 plus 48 is 63. So 63 grams over 1 mole. And look at that. I have that set up wrong. I got to worry about canceling out my units. Okay. Maybe we can edit that part out. So, 55 grams of barium carbonate and 26 grams of hydrogen nitrate. I take this times 1 mole over my gram molar mass for barium carbonate, which is 137.3 plus 12 plus 48, 197.3. My grams cancel out. I end up with 55 divided by 197.3, 0.279 moles. Now keep an eye. It's a 1 to 2 ratio. So let's see, 26 grams of hydrogen nitrate, which would be 1 plus 14, 15, 15 plus 48, which would be 63. So 26 divided by 63 equals over 63 grams equals 0.412. We'll call it 0.413 moles. Okay, now, looking closely there, I would have 1 mole of this, 2 moles of that. This is fairly close to 3. That's fairly close, 0.3. That's fairly close to 0.4. So if I had 0.3 of this, I would need 0.6. As I can see, I don't have double my hydrogen nitrate to react with my barium carbonate. So the thing that would run out, since I don't have double of this, the hydrogen nitrate would run out first. This is my limiting reactant. Okay. From there, I need to determine how much barium nitrate will be formed when that is used. So that is my total. This is my limiting. I need to base my product based on my limiting reactant. So I have 0.413 moles of hydrogen nitrate. I would multiply that. I want 2 moles, my mole ratio, over 1 barium carbonate. So really what I'm doing is I'm taking 4.13, I'm dividing it by 2, I get 0.20, we'll say 0.206 moles of barium, oh I'm sorry, I put barium carbonate, I should have had barium nitrate, but it really doesn't matter because it's still a 1-to-1 ratio. I still get the same number of moles here. Okay, and then from there it's saying what mass, so I need to find grams. So the gram molar mass of barium nitrate would be 2 nitrogens, which is 28, plus 6 oxygens, which is 96, plus 137.3 for barium. That is, the gram molar mass would be 0.206 moles times 261.3 grams over 1 mole, which means I would produce 0.206 times 261.3 is 53.8 grams of barium nitrate. Okay. Now the last one, you would again have to do a whole stoichiometry calculation. I think I'm going to stop this video just because it is kind of long. Hopefully everything's still in the frame, just barely. And I think that's good for now. I'll post one more video of the last problem tomorrow.